Alright, so now I want to look at how to do exploratory data analysis. In our previous tutorial, we look at how to prepare our data preparation, which includes checking for some missing values, duplicate values, and also how to convert our categorical variables or how to recode them. And also, we also look at how to do some data filtering. But now I want to delve deeper into our exploratory analysis. How do we do exploratory analysis? EDA or exploratory data analysis is basically one of the techniques used in analyzing data sets to summarize their main characteristics, often with visual methods. We have two stages for this. We have one of them being data summarization, and the other is about data visualization. Okay, in this part we want to start with data summarization, which is basically going to focus on some numerical summaries or using some frequency tables. Okay, so for data summarization, we want to look at how do we summarize data for quantitative variables. Then we will look at how to also summarize data for some categorical variable. Okay, so in here I want to start with data summarization for the quantitative variable, which we have them to be separ length, separ width, beta length, and beta width. We are using our original data set from our previous tutorial, which has 148 observations. So let's use control the arrow, the down arrow, to basically look at the last observation, which is 148. So control up arrow, we have the first observation. So we have seen that we have 148 observations. How do we start with the numerical summary for quantitative variables? So let's click on Analyze, which is on top of the menu of our window editor, and let's scroll to Descriptive Statistics. Scroll down to Descriptors. Okay, so let's click on this. Alright, so now we are going to select this numerical values. So let's highlight them, right? Only the first four, and drop it in this box. Okay, so now this is what we want to do. Let's click on options. Yep, so we can look out for the mean, standard deviation. So we know for numerical summaries, we can look at for the measure of central tendency, which is basically the mean or sometimes the median, right? And we can also look at for measure of dispersion, which includes standard deviation or the variance, right? But in here, we are going to make use of standard deviation. We can also make use of the minimum or the maximum value. We also have measure of shape, which include ketosis and skewness, right? Skewness basically is a measure that describes or measure the degree and direction of departure from symmetry, right? While ketosis basically describes the thickness of the distribution, which basically determines the heaviness of the distribution tails. So we can also check this and check that. Think we are good to go. So let's come to continue. Alright, so this is what we want to do. Decide for the quantitative variables. Now we also have save standardized values as variables. Why do we need to do this? Sometimes with some algorithm that you want to make use of or some models that you want to make use of requires that these variables are on the same scale of measurement. Okay, fortunately for us, these variables are all in centimeters, but sometimes the data set you have at hand may be of different unit. This may be in centimeters, this may be in kilograms, this may be in dollars and other unit of measurement. So it is appropriate, okay, for some algorithm it's appropriate that you have to scale or you have to put all these variables on the same scale. And one way to do this is to preprocess or transform your variables either by standardizing the variables or by normalizing the variables. Okay, so this is one aspect for us which says we have to standardize the variables. So if you don't want to make use of the original values, then you have to standardize them, which basically going to compute the mean for each variable, subtract it from each of the data point and divide it by the standard deviation of each of these variables. Okay, that is with standardization. With standardization, each of the values is going to have a mean of 0 and a standard deviation of 1. Okay, and for every standardized value, it also tells us how each of the data points, right, or it basically tells us the number of standard deviation each of the data point is going to be away from the mean. That is, you are looking at how each of this, the number of standard deviation that each of this data point is going to lie below or above the mean. So we can basically check this if we want to basically put all the variables on the same scale of measurement, which um, is very vital for some machine learning algorithm. Okay, so we will look at this very soon. So we can check this for now and click on OK to proceed. So click on OK. Alright, so here we go. So we can see that, let's go back to the output variable to see what we see. Alright, so here we go. These are the descriptive statistics. So we can see the count for each of the variables, the minimum value for each variable, the maximum, the mean value, the standard deviation, the skewness, as well as the ketosis, right? So you need to know how to basically interpret each of them. Right, for skewness, for instance, according to literature, if the skewness is less than -1 or greater than +1, the distribution is said to be highly skewed. But if the skewness is between -0.5 and, let's say, +0.5, then the data is nearly symmetrical. Right, for ketosis, according to literature, a distribution with ketosis that is approximately 0 is called mesochaotic. Yeah, mesochaotic. I think I got it right. And a distribution that is basically a distribution that is approximately normal, that's mesochaotic. Okay, it is normal in shape. But a distribution with ketosis that is less than 0 is said to be plateautic. Okay, that is as compared to a normal distribution, it tails are shorter and often its central peak is lower or broader, right, as compared to normal distribution. And a distribution with ketosis that is greater than 0 is said to be leptochaotic, right? That is compared to a normal distribution, its tails are longer and often its central peak is higher and sharper as compared to the normal distribution. Okay, so this is basically how to get a descriptive statistic or the sum of the numerical summary for the quantitative variables. Okay, so I think we are good to go. Now let's go back to our window editor. So we can see in here that we have the standardized values for each of the variables that we check. So this is the standardized values for the sepal length, for sepal width, petal length, and petal width. Now we can also get a descriptive statistic for this standardized value. You realize that the mean value for this is going to be 0 and the standard deviation is going to be 1. So let's use the recent dialog descriptors. So now let's pull this one out from the box. Let's drop them. Okay, and now let's highlight on the standardized values and let's drop it inside this box. Okay, so let's uncheck this, right, and let's click on OK to proceed. So with a descriptive statistic for the standardized values, we can see that each of the values has a mean of 0, that's the mean value, and the standard deviation is 1, right? So this is one way of transforming or preprocessing your variables. The other way is by normalizing your values. With normalization, you are going to have a range of value where the minimum for each variable is going to be 0 and the maximum value is going to be 1. Okay, I think we are good to go. So now let's look at how to get the descriptive statistic for, or how do we summarize our data summarization for, let's say, our categorical variable. So let's go back to the let's use analyze on the menu of our window editor. Okay, so let's click on this and let's go to descriptors, click on frequency. Alright, so we don't need these variables anymore. We need a categorical, so let's highlight and pull it back in this box. So let's use this. Now let's check that of the species, right, and pull it inside this box. Alright, so what are some of the statistics that we need? For categorical variable, we can't use the mean, but we can use the mode, right? And I think we are good to go. Okay, so let's click on continue. Then we can also display the frequency, right? For categorical variable, getting the frequency distribution is very vital. Okay, so I think we are good to go. Let's click on OK to proceed. Okay, so here we are in our output window, and we can see the result. We have 148 values. We have already prepared this data, so we can see that this gives us a count for each of the categories of our species plant. Setosa has 49, Vesicola has 50, and Virginica has 49. So in total we have 148. We also have the percent for each of these labels, and the cumulative percent, right? So this is basically how to do data summarization, right, for some quantitative variables and categorical variables as well.